and there is regular P wave, and the PR intervals are longer than the normal. It's more than 5 small squares.
Okay.
So I think it's first degree AV block.
What about the axis?
Axis is it's normal axis.
Okay, one is positive, but close to the 0, a little bit more positive. So this is why it's less than 90, but it's close to 90. So let's see about 80 degrees. Okay, so when you start rhythmic, heart rate. Yeah, you said about 90, 95. Good. Next one, impulse formation center. We do have P waves, okay, in lead number 2, positive and negative in AVR, sinus rhythm. Every P followed by QRS, okay, but the PR interval is longer. Later on, when we talk about hypertrophy, you should evaluate that this P is okay. This is it's 0.1 second, and how tall is it? This you can rule out any kind of hypertrophy. After the PR interval, fine. Now you found out the PR is longer than 0.2 second. Okay, period. Next one, QRS complex, width of the QRS complex. Okay, that's narrow. Okay, good. And the axis is normal. The closest one is lead number 1. So this is why it's 90 or 80 degrees. This is what we have. That's it. So far, this is what we learned. Okay? Okay. Next one. Who has 102?
That would be me.
Okay, your turn.
Sure. So I can see that it's regular rhythm.
Okay.
The heart rate is around a bit over 60 beats per minute. And there is a regular P wave that's followed by the QRS complex.
Okay.
But the PR interval is longer than the 5 small squares.
Okay.
The axis would be also the lead 1 and AVF being positive, and lead number 3 being the closest to equiphasic. So I would say around 30 degrees.
Correct. And the QRS is narrow, so there's no
So I would get.
Yes. So no intraventricular conduction
narrow.
abnormality. Okay, narrow. So no intraventricular conduction abnormality. That's it. Period. All right. Good.
Yes.
All right. 103.
So for 102, what was the block?
AV block. First degree of AV block.
Okay, so same as 101 then.
Yeah, it's exactly the same.
Okay, thank you.
Okay, you're welcome.
I'm doing the 103.
Okay, do it.
For 103, I can say it's the normal rhythm.
Well, I don't think that's a normal rhythm.
Okay, it's really hard to say whether it's a normal or not. So this is not a normal rhythm. Good. And it has 75 beats per minute.
Okay, the average rate, because this is arrhythmic, and the average rate around 75. Okay.
Okay, arrhythmic, normal heart rate, and the axis is normal as well, close to 60 degrees.
Well, I don't think that is 60 degrees because one is the smallest one, so it's getting closer to the 90, but one is positive and AVF is positive, is normal. And if you compare the 2 and 3, it looks like almost the same, except 2 is a little bit bigger one. So I would say 80. This is why, because 1 is almost equiphasic.
Oh, okay. Thank you. So it's close to, again, looking at the letter. Okay, good. So close to 80, like you said. And I can see some P wave is not conducted, or the RR is dropped.
Okay, so we have dropped P. So we do have P waves, okay, and that P is positive in lead number 2, negative in AVR. That's a sinus one. But we do have some dropped P's, it meaning that is not conducted. So we have a second degree AV block. Which type?
And I can tell it's a Mobitz 1.
Because?
Because the PR intervals gets longer.
Yeah, or?
Or using an RR interval.
No.
Harder for me. So
no. I suggested you that when you do have this kind of situation, Look at the last conducted PR and compare to the first conducted PR. Don't look at whether the PR getting longer. Last one, first one, period.
Okay. Last PR and the first PR.
Okay,
Thank
you don't need to use this RR. It's okay. That's it's fine. It can be used, but in this case, we do have the A and the B both. So you don't need to use this kind of RR evaluation. Okay, and the QRS is narrow, so there is no intraventricular conduction abnormality. Period.
Thank you.
Okay.
I'm sorry, please, I have a question about 103.
Yes.
You said lead 1 was equiphasic, isn't
almost,
it?
Almost an AVL, as you say, that AVL maybe it's a little negative. It's okay. It can be around 60, but a little bit, I think it's more than 60, because if you had a 60, 3 and 1 should be equal.
Okay. Thank you.
Okay. 104.
Yeah, that's me.
Good.
So the first 3 are intervals are pretty equal, but then there's a dropped QRS complex. So I'd say it's pretty rhythmic.
It's not rhythmic.
Oh no, yeah, because we have a missing QRS complex.
Okay, here you cannot say that, well, this is an awful guy, but I like him, so it's okay, I'm taking him. So no, that's arrhythmic, fine.
Arrhythmic. The heart rate is around 80, between 80 and 85 beats per minute. I looked at lead 1, which is pretty equiphasic, and AVF is positive, so I'd say the axis is pretty normal, around 90. And because the PR intervals are more than 5 blocks, and I can tell that the last PR interval before a dropped QRS complex is longer than the first one, I'd say this is a 2nd degree Mobitz type 1.
Correct.
Yeah.
And the QRS is narrow, so there is no intraventricular bump. Okay, good. All right, next one, 105.
Yes, it's me. I put it irregular, the rhythm.
Yeah, that's a very nice ECG, very nice. Okay, it's irregular, fine.
The heart rate is around 55 BPM.
Okay.
And for the diagnosis, it's AV block 2nd degree.
Well.
Bit 1, because I see that the PR interval is becoming longer and longer, and also...
I don't think so. I don't think so. First of all, okay, let's see where are the periods. First, this is what we have to see. Okay, if you start here, 1P, other P, other P, other P, other P, other P, other P. Oppa, this is different one. Try to get a little bit closer. Maybe I try it. Okay, this way I can get closer. See? Look at this P and this P. This P is not the same as this one. Yes? So that's a premature atrial beat. That's a premature atrial beat, and we do have a longer conduction here.
Okay.
So that's different from the others. If you look at the others relatively, the PR is not changing too much. It's not changing at all. Okay, it's not changing. So I would say that this area, only except this first one, this area, we do have a pretty normal connection between P and QRS, So here you could say that this is a 2-to-1 conduction abnormality, except here, because here we do have an atrial premature beat.
Okay.
And that's interrupting this 2-to-1 conduction. But I would say that this is a 2-to-1 conduction abnormality.
2-to-1, okay.
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 So that's a weird one, but this is what we diagnosed. And what about axis?
I would say it's between 30 degrees and 60 degrees.
Okay, 30 and 60. Why did you say that one? Because
lead 2 is the highest. The R is the highest in lead 2.
Yes.
So it would be 60 degrees, but
a little bit closer to 120. So I would say that 70.
Okay.
It's not around 30 because if you had closer to 30, so they're getting closer to 1. 1 should be bigger than 3, but 3 is bigger than 1.
Okay.
Okay. Now another weird thing. Okay, QRS is narrow, but other weird thing that you can see here, that the ST elevation. See?
Yes, this is for
the next one. Yes, for the next.
But we can say today it's like inferior infarctus? Or?
Yeah, that's an inferior posterior, inferior posterior MI. Yes. The next time you will see it. Okay. Now, all right. Let's see 106. Okay, 106. Yep.
Can you explain the 2 to 1 AB block again above?
Okay, if you look at the PR interval, the PR interval is pretty normal or closed or doesn't change, okay? Here, in this area. Yes? But we do have an extra P. So we have twice as much P as the conducted P. So we have a conducted, not conducted, conducted, not conducted, conducted, not conducted, conducted. Aha, that's different one because that's a premature atrial beat. And here again, starting conducted, not conducted, conducted, not conducted. Okay.
Thank you.
You're welcome. 106. Wow, that's a tricky one. That's a tricky one. Who has 106? Hopefully nobody. Yes? Now, if nobody has it, I will tell you what is it. Okay, first of all, if you look at the rhythmicity, it's not rhythmic. You can see it. Only one problem, that we do not see any P wave, yes? Instead of seeing a nice P wave, we do have spikes. Yes? Can you see the spikes?
Yeah.
So that's an atrial pacemaker. Okay. Looking here, this looks like this atrial pacemaker and the connection between the atrial pacemaker and the ventricle. See? The conduction is getting longer and once is not conducted. So it's meaning that we do have a second degree AV block, Mobis type 1 with an atrial pacemaker. Now that's a tricky ECG, yeah? Hopefully nobody had this one or whoever had it is not here, but that was a tricky ECG. And another thing that you can see, narrow one axis is around the 0 because AVF is equiphasic, nothing else, only this kind of spike. So if you do see spikes and this spike initiates a QRS complex, you do have a ventricular pacemaker. If it initiates a P wave where you don't see any P wave, but after you have a gap, and that's a PR or some kind of conduction occurring, that's the atrial pacemaker, what we have here. Okay, good. 107, who has 107?
I have 107.
Okay, good.
So it's not rhythmic. It's like
it's rhythmic. It's rhythmic.
Oh, it is rhythmic?
Yeah, look at here in the bottom.
I know, I noticed the last one was rhythmic, but then the other ones weren't.
Yeah, because that's only a short.
Okay.
Here they changed the leads. Okay, all right.
Okay. And so I think it's a high degree block. The axis is normal.
I don't think that is a high degree.
No?
No, because it's rhythmic.
Oh, yeah.
High degree cannot be rhythmic.
Yeah, that's true. Yeah, so it's rhythmic. And then I counted the beats per minute being 50.
Yes.
Yes.
Very slow. Yes.
Yeah. Okay.
And
so if it's not an AV block, then
yes, that's an AV block. That's an AV block.
Yeah.
Look at. I magnify it a little bit. Okay. Again, we have twice as much P's than conducted. This is not conducted, conducted, not conducted, conducted, not conducted, conducted, not conducted, conducted. Again, we have a 2 to 1 AV block.
Okay.
Okay. So if you do see this kind of P wave. Now, another thing, very good to see this, because later on when we talk about hypertrophy, this is the shape of the P wave. It's normal. No, it's wide and nudged.
Yeah.
So this is why you can say that's a left ventricular hypertrophy. Later on, we will learn it, but not now. But again, we have a problem on these ECGs, as you see here. Axis, as you said, that what was the axis? It's around.
It's normal?
Well, it's not normal.
No.
Because one is positive, AVF is negative. It cannot be normal. That's it. Lead number 2 after you have to look at positive. So it's between 0 and -30. That's a left deviation.
Left deviation, okay.
Left deviation, okay. Good. Let's see 108. Wow, 108.
That's mine.
Okay.
And first of all, it is rhythmic.
Okay.
And I got ventricular rate and the atrial rate respectively. So the ventricular one is 35 BPM.
Okay.
And the atrial one is 150 BPM.
Okay.
So the atrial one is way larger than the ventricular one.
Yes.
And for the axis,
yes,
I think the lead one is almost the equiphasic one. Okay. So it will be 90 or -90, but the AVR and the AVL shows the positivity. So it's about -90 degrees. So it is extreme left deviation.
Okay, so between -60 and -90, I would say it, okay?
Okay. And so I think this is a high grade AV block. Is it right?
So that was a high degree AV block, yes?
Block.
Yes, and the conduction, I'm trying to use another headphone, but it doesn't work, okay? So I'm sticking to my old fashioned, okay? So that means that's a high degree AV block, and the conduction ratio, what is the conduction ratio?
4:1.
Okay, let's count how many P wave we have. 1, 2, 3, 4, 5. 5:1. Okay, so 1, 2, 3. Well, it's changing. It's changing, but you can say 4:1. Yes, you are right. 4:1. Okay, 4:1 is okay. Good, very good. All right. Let's see the next one. And we haven't finished yet. We haven't finished yet because QRS complex.
Yeah.
Look at the QRS complex. I magnify this QRS complex. Look at in V1. It's wide, 1, 2, 3. It's 0.12. 0.12. Okay. And in V1, you do see this wide R complex. So that's a right bundle branch block. Okay, and you do see this slurred or widening of the S wave, okay, on the left side. So that's a right bundle branch block. Look at here, see in lead number 2, this last part is longer. Okay, so that's a right bundle branch block. And what was the axis? The axis was almost -90, -60, -90. So that's we have two diagnoses here. We do have a right bundle branch block and a left posterior hemiblock. So we have a bifascicular block and a high degree AV block. Wow. How do you like it?
Oh, it's great.
All right. So never ever forget about to look at the QRS, the width of the QRS as well, because that's important. Okay.
Okay.
Good. 109. Oh, that's a tricky one again. That's a tricky one. Hopefully you figured out. Okay, let's see who has 109.
Okay, I have the 109.
Okay, and
from the
this is only one lead. This is one lead. Lead number 2, all the way.
Yeah, from the first, I can say it's a bradycardia because the R distance is longer than usual, about 40 beats per minute.
Okay.
And you can say that it is second degree 2 to 1 heart block because
No. It cannot be second degree for sure. Because second degree means we do have arrhythmia, and that's not arrhythmic, that's rhythmic.
No, like 2 to 1 heart block or something
okay,
like that.
You can talk about 2 to 1, but only one problem with the 2 to 1 that the PR should be constant. Now let's look at whether the PR is constant or not. Here it's okay, here it doesn't change. Okay, in the first row is all right. But what about the next row? Oh, look at here.
It's kind of changing.
Yeah, so it's no connection between the P and the QRS. This is what it meant. So that's not a 2 to 1, that's a complete third degree AV block.
Oh, okay.
It's an AV dissociation, and you do have a junctional escape rhythm.
Yeah.
So this is why is it important to look at the PR interval, whether it's changing or not. Because it's maybe not every bit. If it's a teeny tiny changes, you can see relatively takes much longer time when the piece gets inside the QRS complex, or when you do see that the P is not exactly proportional to the QRSs. If you do have a heart rate difference between, let's see, the SA and the junctional rhythm, and not close to the 2 to 1. For example, if you do have a 60 rate of 60 of the sinus and the 30 of the junction, exactly proportional, so the PR is equal. But when you start to have, for example, 75 sinus beats and only 30 AV beats, well, immediately you can see that the PR will change.
Okay.
Okay, so you can ask the patient, for example, to move a little bit or step down up, and after you can look at the ECGs again, or take a deep breath, for example, because that will slowing down the sinus activity. Again, that you can see that the PR will change. Okay.
Okay.
Good. Nothing else.
Can I say it is bundle branch block?
No, you cannot.
No. Okay.
Because first of all, the QRS is narrow. If you had a wide M complex in lead number 2, you could say that's a left bundle branch block, but here not. And especially in left bundle branch block, again, the TB negative, very similarly to the ventricular rhythm or ventricular escape rhythm. Okay, 110. Who has 110? Nobody. Again, nobody is here. Wow. Okay, so I have to do it, if you say so. Now let's see, what can I see here? First of all, it's rhythmic, yes? We can agree? It's rhythmic. Okay, the heart rate is very slow because if by counting, it means 1, 2, 3, 4, 5, 6, 7, 8. So we do have 8 big square. So 300 divided by 8, it's around 30 some. Okay, so 30 beats per minute, very slow. Okay, we do have P waves. Yes, okay, we do have P waves, all right. And however, look at the PR interval. Well, it's not the same. If we are lucky, look at that one. We have the 2 Ps. So we know that the rate of the Ps is around 75. Okay, so possible we do have some other hidden piece inside the QRS complex. We can hunt for it, and sometimes we can see it and we are magnified. Okay, that would be nice. Okay, so here, for example, 1 P is here, another P is here. I would bet another P is right here. P is here, maybe here, I don't know. So it's meaning that this P is independent from the QRS complex. What can it mean? It meaning that this patient has a complete AV block, third degree AV block, and the junctional escape rhythm, because the rate is around that one, and the QRS is narrow. Well, but we do have an ST elevation and the total T wave. This is for the next seminar, what we are discussing. Axis. One positive, AVF is positive, that's normal. The axis could be close to lead number 2 or around 60 or so. Okay. And the QRS narrow, nothing else. Yes, that's it what we have. And of course, this patient has a hyperacute or inferoposterior STEMI. This is what the patient has.
I'm sorry, but what was the junctional escape bit?
This, all. Because there's no connection between the atrial and the junctional connection. So it's a ventricular contraction. Here, this is a PP interval. And if you get the paper, mark it, shift it, and you will find some hidden piece inside the QRS complex. This is what I showed. Okay. So that's a 3rd degree AV block with a junctional escape route. Okay. Okay. 111. Now that was one of, wow.
Yes, it's me. So basically, it is rhythm is rhythmic, and you can see here the heartbeat is around 75 BPM. Due to positive lead 1 and positive AVF, we have the left axis deviation.
Okay, one positive, AVF negative is normal. Okay, that's normal. I would say normal. Okay.
Yes. Yes. So the AVL is equiphasic, but the lead 1 it is closest. So the range is from 0 to minus 30 degrees.
No. It cannot be minus because lead number 2 is positive. So that's in the normal range, but it can be around 60 degrees or so. Okay, because the sum is positive, sum is positive, okay?
So the PR interval, it is greater than 0.20 without the disruption of atrial to ventricular conduction. And the heart rate is unchanged. So it's the 1st degree AV block.
Yes, very good. That's a 1st degree AV block. Very good. Okay, now if you're looking at the morphology of the QRS complex in lead number 1 and in lead number 2. See, this is an M complex. It's not wide too much, so that's, I think it's an incomplete, but it looks like an incomplete left bundle branch block. Because that's an M, is a notched R in the lead number, and the EVL as well, see? RSR, in lead number 1, RSR. So that can be an incomplete left bundle branch block because the duration is not longer than 0.12 seconds. Huh?
Yes, okay.
So always you have to look at the duration plus not only the duration, but you have to look at the shape of the QRS as well. On the left side and then the right side. Okay, 1012.
It's me.
112, not 112, 112. Okay, let's see. What did you get out from this one?
First of all, it looks rhythmic. But we can see that the P waves has been not conducted in the middle.
There are several pieces not conducted, okay?
So I think it is AV block, right? But it's gonna be 4-1.
1, 2, 3 to 1.
Oh, 3 to 1, sorry. Okay. And for the axis, it seems like the 1 is negative and the AVF is positive. So we can say it's right deviation.
Okay, extreme right deviation, okay.
Yes. The angle is gonna be around 120 because it seems 3 is really big and APR is minus.
Or equiphasic. I would say it's equiphasic because you have a positivity is here, okay?
Okay.
And QRS?
QRS.
Look at V1.
Is it right bundle branch block?
Yes, you can see the slurred S
RSR.
wave. Exactly. So you do see a right bundle branch block, plus you do see a extreme right deviation. So that's again a bifascicular block. Okay, that's a bifascicular block. And if you get closer, maybe the PR is longer than 0.2. So you can see that it's trifascicular block. Okay. Okay, good. Let's see 113. I think, yeah, maybe we had this. No, we have not. Okay, let's go. Who has 113?
It's me.
Okay.
It is irregular heartbeat.
Okay.
And then when I calculate heart rate, it says like 80 beat per minute.
Okay.
And which is in the normal heart rate.
Okay.
And for axis, when I check the read 2, it's almost equiphasic. And then when I check the AVL is perpendicular to the lead 2.
Okay.
When I check the AVL, and then it says around minus 30 degree. And I also do another approach. And then when I use it, it's like axis is in between like 0 to minus 30 degrees. So it shows the left deviation.
Yes.
And then I can see that there are like for lead 2, the last one, it shows the dropped P, like dropped RR interval. And then dropped RR interval is twice as much as the last RR interval. And then PR interval and RR interval is constant. Okay. So I would say it is second degree AV block of Morbius type 2.
Correct. Correct. Very good. Correct. Okay. QRS is narrow and no other sign of any kind of intraventricular conduction of novelty. Good. Very good. Very good. Okay. 14.
That's me.
Okay.
So I think it's not rhythmic.
It's rhythmic.
Oh, it's rhythmic.
Yeah, it's rhythmic because you have to look at this area. This is not. Okay.
Okay. And heart rate was around 40 beats per minute. And like P wave overlaps with T waves. And PR intervals are longer than normal. It's around 0.28 seconds.
Yeah, but constant, okay.
Yeah. So I think it's third degree.
No. It's can be third degree AV block because the PR you said is okay, it's constant but longer, and you have twice as much. This is
2 to 1.
Yeah, that's a 2 to 1 because that's not conducted, not conducted, not conducted again. So that's a 2 to 1 AV block what we have. Okay, 2 to 1 AV block what we have. Okay, good. 115. Who has 115?
I do.
Okay.
Okay, so the rate was around 75 BPM. It was positive in lead 1 and also positive in AVF. So an equiphasic in AVL, which means that lead 2 would be perpendicular. So that's so like around 60, but a little bit less since lead 1 is bigger than lead 3. And I thought that it would probably be second degree AV type 2 Morbius block.
Second degree AV block, Morbius type
2.
Why?
Because when I zoomed into lead 2 at the bottom, like the P waves weren't like the same. They look different. Like
okay, let's look at here. Let's look at here. That's it's simple. Okay, that's a PR. That's a PR. That's the PR. This is not conducted. That's conducted. Okay. The last conducted. This is this here.
Yeah.
Okay, that's longer than the first one. Okay, so that's Mobitz type 1, not Mobitz type 2. And if you look at the RR, see?
Yeah.
Longer, shorter. It's changing. Longer, shorter. So this is why that's Mobitz type 1. Okay.
I'm sorry, about the looking at just the P waves, how do you differentiate between type 1 and type 2?
Only the P wave?
Yeah.
Okay, very simple. Where you have no conduction, okay, this is conducted, this is conducted. Now here, very difficult to see the P, but here you do see the P, because on the ST, see, somewhere here.
Yeah.
This is still conducted, but this is not for sure.
Yeah.
So this is why that's PR is longer than this PR. This is how you, let's see, calculate it.
Okay. Thank you very much.
You're welcome. Okay, next one, 116. Who has 116? Nobody.
I did.
Okay. It's your turn.
So first heart rate. And do you hear me?
Arrhythmic. Heart rate is?
Heart rate is it's arrhythmic.
The heart rate cannot be arrhythmic. The rhythmicity is arrhythmic. The heart rate is a certain number.
Heart rate is around 60 BPM.
Okay.
And heart axis. The read one is positive and read AVF is also positive. So
no. AVF is negative. Look at here. AVF is here. AVF is negative. One is positive, AVF negative. So this is not normal. This is the left deviation because lead number 2 is positive. So this is between 0 and -30. Okay, go on.
And I'm looking at the second read.
Okay. This is a second read.
Yeah.
Okay.
The rhythm of P wave is, no, there is regular P waves, but some P waves are not conducted. So it's gonna be the second degree AB block, and looking at the PL intervals before the first one and the last one. The last one is longer than the first one, so it's gonna be the Mobitz type 1.
Yes, Mobitz type 1. Okay, go on. Next one that you have to look at, the width of the QRS.
Normal and
this is 1, 2, 3, 3.5. So it's bigger than 0.5 seconds. So that's wide.
That's the left.
No.
Right. Right one, yeah, right.
You do see this RSR in V1. And on the left side, you do see a little bit slurred, okay, S wave. So this is a right bundle branch block, okay? Right bundle branch block, okay?
Yes.
And you do have this first degree, not first degree, that's second degree Mobitz type 1 AV block, okay? Okay, good. Anybody has this 117? Nobody. Everybody presented everything.